Hi children, let's continue with our fourth chapter, carbon and its compounds. In the previous class, we learned about the versatile nature of carbon. Then we learned about saturated and unsaturated compounds too. So in this class, we will learn about saturated hydrocarbons. Before that, let's see what are hydrocarbons. What are hydrocarbons? Compounds formed between carbon and hydrogen. Compounds of carbon with hydrogen are known as hydrocarbon. Compounds of carbon and hydrogen are known as hydrocarbons. So hydrocarbons are of two types, saturated and unsaturated. Hydrocarbons are of two types, saturated hydrocarbons and unsaturated hydrocarbons. So this classification is based on the nature of carbon to carbon bond. So depending upon the nature of the bond between carbon atom, carbon-carbon bond means bond formed between two carbon atoms, carbon-carbon bond. Nature of the bond between carbon atoms, we have two types of hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons. Okay, so first we will see what are saturated hydrocarbons. So the compounds formed between carbon and hydrogen are known as hydrocarbons, and based on the nature of the carbon-carbon bond, whether it is single bond, double bond or triple bond, we have two types of hydrocarbons. The first one is saturated hydrocarbons. Saturated hydrocarbons. So the compounds of the hydrocarbons in which compounds of carbon, that is hydrocarbons in which all the carbon atoms are joined by means of single bonds only are known as saturated hydrocarbons. So only single bonds between carbon atoms in saturated between carbon atoms. So bonds formed between carbon atoms, all the bonds are single bonds. Such compounds are known as saturated hydrocarbons. So the hydrocarbons in which all the carbon atoms are joined by means of only single bonds are known as saturated hydrocarbons. The other name is alkanes. They are known as alkanes, saturated hydrocarbons or alkanes. Now we have to write the name, formula and structure of the first 10 alkanes, saturated hydrocarbon or alkane. Okay, for that we need the general formula of alkanes. It is Cn, small letter n, this is subscript Cn, H2n plus 2, Cn H2n plus 2. So where Cn H2n plus 2, where n is the number of carbon atoms. So we have to write the name, formula and structure of the first 10 saturated hydrocarbons or alkanes using this general formula Cn H2n plus 2, where n stands for the number of carbon atoms. For example, n is equal to 1. What will be the formula? C1 H 2 into 1 plus 2. So what is it? C. So C1 you need not write. C stands for 1. So C H4. 1 you need not write in the formula, that we have learned in 9th standard. So just write C, it means that 1 carbon atom. So 2 plus 2, 4. Name of this compound is methane. Name of this compound is methane. Now its structure is This is how we write methane. C then 4 valencies satisfied with hydrogen atoms. Now, N is equal to 1, we write meth. So, when we come to unsaturated hydrocarbon also, the name starts with the same prefix, meth. Suffix come from whether it is alkane, ANE. This ANE is for alkane. So, N is equal to 1, the name starts with meth. To that you add alkane, ANE, then it becomes methane. Similarly, N is equal to 2, it is eth. N is equal to 3, it is prop. N is equal to 4, it is but. N is equal to 5, it is pent. N is equal to 6, it is hex. N is equal to 7, it is hept. N is equal to 8, it is oct. N is equal to 9, it is non. And for N is equal to 10, it is dec. Okay, so for alkanes, saturated compounds, if N is equal to 1, we add ANE. N is equal to 1, methane. N is equal to 2, when you add ANE, it becomes ethane. N is equal to 3, it becomes propane. Then butane, pentane, hexane, heptane, octane, nonane, decane, etc. So, ANE is from alkane, ANE from the name alkane. Okay. So, this you have to by heart. Meth, eth, prop, but, pent, hex, hept, oct, non, dec. N is equal to 1, meth, N is equal to 2, eth. Like that up to 10 you have to by heart. So, to that, depending upon whether it is single bond, double bond or triple bond, ANE, ENE, YNE you have to add. That will make the name. Okay. So, we will start. So, I will write the general formula on the top, CnH2n plus 2. This is for alkanes. So, N is equal to 1 as we have already written, C1 H 2 into 2 plus 2, H2n plus 2, making it CH4. Its name is methane. Structure is only one carbon atom is there, around there 4 single bonds which are joined with hydrogen atoms. Now, N is equal to 2. So, C2 H, sorry, this is 2 into 1 plus 2. H 2 into 1 plus 2. Here it is 2 into 2 plus 2. So, what is the formula? C2 H 4 plus 2, it is 6, C2 H6. So, N is equal to 2, name start with eth, add ANE of alkane, making it ethane, name is ethane. Now, there are 2 carbon atoms. So, I will draw 2 carbon atoms. Here all the bonds are single bonds. So, draw a single bond between carbon atom. Now, valencies. First carbon has 3 free valencies. Second carbon also has 3 free valencies, where you have to write hydrogen atoms. Okay, so this is the structure of ethane. So, N is equal to 2. This is known as molecular formula. C2H6 is called its molecular formula. This is the chemical name. This is structural formula. Now, you can condense it and write, we call it as condensed formula. Condensed formula. How will you write it? Write C, first carbon atom. Around the first carbon atom, how many hydrogens are there? 1, 2, 3. 3 hydrogens. So, write CH3. Here is a single bond. This middle single bond CH3. Then write the second carbon. Around it there are 3 hydrogens. So, making it CH3, single bond CH3. This is the condensed formula. Molecular formula. This is the structural formula, and the last one is the condensed formula. So, everything you have to write. Now, the next one, N is equal to 3. C3H2 into 3 plus 2, making it C3H8. C3H8. What will be the name? N is equal to 3. Start with prop. Since it is alkane, we write it as propane. Okay. Now the structure. Coming to the structure. 3 carbon atoms. Since it is saturated, all the bonds are single bonds. Now, isn't it? First carbon atom has 3 free valencies, second carbon atom has 2 free valencies, and the third carbon atom has 3 free valencies. Fill it with hydrogen. Make sure that it matches with the formula that we have written, C3H8. C3H8. The formula is correct. This is the structural formula. This is the molecular formula. Now we will write the condensed formula. Take the first carbon atom. How many hydrogens are there around it? 3. So CH3. Bond is single bond joining to the second carbon. Now how many hydrogens on the second carbon? 2. So CH2. Again a single bond joining it to the third carbon, which is attached to 3 carbons. So CH3, CH2, CH3. Again you can check 3 carbon atoms, C3, H3 plus 2, 5 plus 3, 8. C3H8, propane. This is the condensed formula. Now, N is equal to 4. Butane. The formula is C4H2 into 4 plus 2. What is it? C4H10, making it C4H10. So draw 4 carbon atoms in a straight chain. Fill in, write the valencies, free valencies first you represent, then fill it with hydrogens accordingly. Always make sure that each carbon atom has only 4 valencies. Don't make it more than 4 or less than 4. So this is the structural formula. You can see that CH3, CH2, CH2, CH3, making it C4H10. Shall we write the condensed form? First carbon, 3 hydrogens are there around it, CH3. Second carbon has 2 hydrogens, so CH2. Again, the third carbon has 2 hydrogens, CH2. Last one, CH3. Again, the total number is C4H10, condensed formula. So this is butane. Now, C5H2 into 5 plus 2. So what is the formula? Molecular formula is C5H12. Name for 5 carbon is pent, add a ANE, so it makes it pentane. So 5 carbon atoms with single bonds. Represent all the free valencies around each carbon atom and then write hydrogens. So this is the structural formula. Now write the condensed form. First carbon atom has 3 hydrogens around, CH3. Second one 2 hydrogens around, making it CH2, single bond, CH2. Again carbon 5. Carbon 4 has 2 hydrogens, CH2, CH3. You have to count the number of carbons and hydrogen and see that the formula, the condensed formula and the structural formula, the numbers match with that in the molecular formula, C5H12. Okay, so this is pentane. Next one is N is equal to 6. C6H2 into 6 plus 2. So C6H14. Name is hexane. So 6 carbons. This was the carbon skeleton that we wrote in the beginning of this chapter. 6 carbons in a straight chain. Represent all the free valencies. Always make sure that the valency of carbon should be 4. Fill it with hydrogen atoms. So this is the structural formula. Now make it into condensed formula. CH3, CH2, 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 CH3. So the numbers of carbons and hydrogens in the structural formula and molecular condensed formula matches with that in the molecular formula. C6H14. So this is hexane. Now the next 4. N is equal to 7, N is equal to 8, N is equal to 9 and N is equal to 10. You do by yourself. This one will be, formula will be C17H16, C8, C9H20, C10H22. Names also I will write. Heptane, octane, nonane and decane. So the structural formula and condensed formula of these 4 compounds you have to write by yourself, otherwise you will not learn it. Okay. N is heptane, octane, nonane and decane you have to do yourself in the same way we have done it before. Now we will draw the electron dot structures. First few alkanes. First one methane. First one methane. So methane has CH4. So 1 carbon atom, 4 hydrogen atoms. Represent the valence electrons only. Carbon has 4 valence electron, hydrogen has 1 valence electron. Okay, so this we have already done. Hydrogen needs 2 electrons to attain stability. Where the electron dot structure of methane we have already done in the beginning of this chapter. So all the hydrogen atoms are stable now. Take the middle carbon atom. It already has its own 4 electrons. Then it takes 1 electron each from the surrounding hydrogen atoms, making the total number of electrons in its circle 8. 4 plus 4 making it 8. So what is its structure? Everywhere the nature of the bond is single bond. Only 1 pair of electron is shared on all the sides. So making it all single bonds. So this is methane. This is the electron dot structure of methane. Now we will try to write it for ethane. C2H6. Okay. So 2 carbon atoms. Write 2 carbon atoms. 3 around the first carbon atom and 3 around the second carbon atom. Now write the electrons. Each carbon atom has 4 electrons each. Hydrogens have 1 electron each. Each hydrogen atom has 1 electron. So first we will draw the circles around each hydrogen, making it 2. Making the number of electrons inside the circle of hydrogen 2. Okay. Now take the first carbon atom. Carbon has its own 4 electron, 4. Then count the hydrogens around it, 1, 2, 3. So making it 7. It needs 1 more electron which it takes from the second carbon. So carefully draw the circle in such a way that carbon its own 4 electron, 3 electrons from the neighboring hydrogen atom plus 1 electron from the second carbon, making it 8 inside the circle of the first carbon. Same way, second carbon its own 4 electron, then 3 from the connected hydrogen atoms of 7, then 1 from the first carbon. Okay. So in the middle you can see that there is a pair of electron shared between the carbon atoms. So between the 2 carbon atoms there is a pair of electron shared, making it a single bond, and all the hydrogen atoms are also linked by sharing one pair of electron, making it all single bonds. The bond between the carbon atom is single bond, and the bond between carbons and hydrogen are also single bonds. So this is the electron dot structure of ethane. Okay, so that's all. Thank you, children.